Question for astronauts. Where your poo-poo go? I'll translate. Where does the poop? What happens to the poop? Hi, I'm Mike Massimino. Today I'm going to answer your questions on Twitter. This is Space Support. At Happy Grampy asks, NASA, what do astronauts do as they're blasting into infinity and beyond at 37.3 bazillion miles per hour under 27.2 Gs? That's only part one of the question. There's more to follow. But with those numbers, I'm not sure what you would do. Blasting into infinity and beyond, don't sign up for that. We go to definite places. I went to the Hubble Space Telescope. You can go to the International Space Station. Have your pick. 37.3 bazillion miles per hour seems a little bit too fast. I think that's over any speed limit. Now I feel like a slowpoke. We actually, in orbit, we go 17,500 miles an hour, and it says under 27.2 Gs, which I don't think that would be pleasant either. We take up to 3 Gs. Are they telling jokes, throwing up, praying, holding onto their seats for dear life until they're in orbit? Pretty much all of the above. I would say you hit just about everything. Joke telling is more for the launch pad before you go to space. So you're like sitting there lying on your back for a few hours. Typically it was a responsibility of the pilot to supply jokes. That was their job. Do I remember any jokes that the pilot said on the, no. Maybe I just wasn't paying attention like I should have to the jokes because, you know, we're about to launch into space. I also played tic-tac-toe with my buddy and rock, paper, scissors, that kind of thing. Throwing up really doesn't happen until after you get to space. That's more of a zero gravity issue, so you're not throwing up during the launch. Praying, absolutely, throughout the launch, I found myself doing that. And holding onto your seats, you're strapped in, so you don't have to really hold on to anything. It's all those things, but it's also an amazing experience. At Peter Peach asks, why do astronauts need belts in space? And I'm looking at a photograph of my friend Megan MacArthur, and they're wearing belts. So why do you need belts in space? Kind of a good question, but I think it's just to keep your pants up. You're not gonna have gravity pulling your pants down, but if your pants aren't fitting really well, they'll kind of float around you. But having a belt, I used a belt. In fact, look at this. I'm using a belt now. I wore this belt in space. This is actual a flown in space belt. So I brought my own belt to space to keep my pants on correctly, and I think it's more of a comfort thing. And also maybe it's an excuse just to get a belt flown in space, because I was able to bring it home and wear it. This next one is from at Miguel Tavares. How do astronauts get leverage when attempting to unscrew tough bolts? You can use your body and gravity on Earth, so seems a little difficult while floating. This is a really good question, and something we do think about. As Miguel says, when we're on Earth, you can brace yourself against something, and you're on the ground, you're not floating away. In space, when you push on something, you're gonna go the other direction, so you're really not gonna get anywhere if you do that. What we do is we make sure that we are stable. So when I was working on the Hubble Space Telescope, my feet would be in a foot restraint, so my feet are nice and solid, and then I could react that force through my feet. If I didn't have my feet in foot restraints, I would try to push the wrench and my feet would go flying this way. Another interesting thing, maybe a little more advanced to think about, is when you're undoing a bolt or you're going to a hard stop on a bolt and you get to the end, it's gonna give you a kick. Well, if you're not steady, the tool will go flying. So we would always think about reacting it with our arm. We're out there in our spacesuits, we'd be in our foot restraints, and I'd always have my arm in position to absorb that kick that we would get at the end. So we're a lot steadier on Earth when we work with tools and work on things. In space, it's a little more challenging, but I prefer it. It's a lot more fun. At Dima Haj, question for astronauts, so only for astronauts. Where your poo-poo go? On the space shuttles, we did have a commode. It was not a flush toilet. It had a seat on it. It was fairly complicated. You had to turn it on and create a vacuum and make sure everything was where it's supposed to. And then every couple days, the poop would be kind of compressed. It was a very ingenious way they did it. It had these different screens. And so poop would be in there, and then one screen would go and compact it, and then more poop, and then another screen. But we just collected that poop over the course of a couple weeks. Everybody's poop went into the same thing. We brought all that poop back with us for no reason other than we didn't know what else to do with it, I think. I don't think there was any science behind it, but that poop came back to Earth, and it was serviced on the ground. Never to be seen again, as far as I know. The space station is a little bit different. The toilet is a can with a seat on top of it and a plastic bag as a liner. So you poop into that can, you close up the bag, and then you get it to the bottom of the can, and you put a new liner in for the next person, clean up, and you're done. Once that can fills up, you take the seat off, you cap it, and you put it in a cargo ship that is now a dumpster. There are certain cargo ships that come up and then they don't return to Earth with anything. They're used as dumpsters. So all your waste, garbage, things you don't need, go in there, it gets sealed off after a while, it re-enters and everything burns up during re-entry. That is a much better way to go. This shuttle toilet was very expensive and complicated. This thing is a can and it works really well. So that's where a poop goes, or poo-poo, as it says. At VWB58, why do astronauts have mirrors on their gloves? This is a really good question, I think. We have mirrors on our gloves when we launch into space in case there's an instrument or a panel or something you need to see behind you. It's really hard when you're launching into space or when you're landing to move your head around. You have a helmet. You can kind of turn your head a little bit, but you can't really see behind you so well. So having a mirror right on your wrist makes it easier to see behind you. If you look closely at a spacewalking suit, the EMU, the EVA mobility unit, and you look at the way these controls are labeled, they're reversed. So when you hold up the mirror to it, it all is in the right orientation. Another thing about the mirrors I thought was interesting is they're not actually glass. You don't want to have glass around the spacesuit. It could shatter, it can cut things no good. So they're actually highly polished metal. They polish the heck out of them to make them shiny. So that's why we wear wrist mirrors. They're very, very helpful, particularly during the spacewalks. At Will Taft asks to at Astro Illini. Astro Illini is my good friend Mike Hopkins, by the way. Real good guy. Mike, if you're listening, how are you? I hope you're doing well. Miss you. All right. Does NASA put any time in the schedule to give first-time spacewalkers a minute to take it in? Yes and no. The first few minutes of your spacewalk are considered to be translation adaptation. Of your very first time spacewalking, it's the first time you're out there, you're in the big suit, just like you were in your training, but we typically train underwater. So when you're underwater and you're moving around, you move differently than when you're in air or also when you're in space. We call it spacewalking, but really what you're doing is using your hands to move around. So as you move around with your hands, you want to go very, very lightly and very slowly. If you put too much oomph into it, that's not a good thing. You'll go flying. Now in the water, you kind of need that extra little oomph because the water viscosity slows you down. It makes you more stable. It requires a little more force to move around. You get to space, there's nothing. There's not even any air to slow you down. There's no resistance at all. So the same type of motion that you would use in the pool will send you flying somewhere you don't want to go in space. So the first 15 minutes or so are usually dedicated to you just to get used to moving around. It's not really look around, take it in, have fun. It's get used to that environment so you can do your job. At Free the Stones asks, space travel question. It's about fuel. Once you get your spaceship pointed in the right direction and get going, do you need to keep your engines going? In other words, do you only need to save fuel to either change speed, direction, or to slow down? If you're in an orbit around Earth, let's take that as the example here, there still is a little bit of drag. Now, if you're familiar with the drag equation, it's velocity squared. If you have a large amount of velocity, like 17,500 miles an hour, you square that, that's a really big number. So even just a little bit of resistance can give you enough drag that eventually the orbit will decay from atmospheric drag. Even though there's just little traces of it, there's still a little bit, you'll get lower and lower and eventually re-enter the planet, which is what happens. Sometimes some spacecraft will slow down enough and they'll come back into Earth. Usually they'll burn up in the atmosphere on re-entry, or if anything makes it through, to land in the ocean or someplace where people aren't around. So it typically isn't a problem, but that will happen. The only way to prevent that is to increase your altitude and go back up and give it a boost. So for example, when I visited the Hubble Space Telescope, we gave it a boost and it raised its orbit and it kept it up. We'll keep it up in space for a longer period of time. If you're on your way to another place, going to the moon or to Mars or something like that, it's going to be a little bit different. You would just need to coordinate your speed, use your fuel to maybe slow down to enter the orbit correctly, but you're not necessarily worried about the orbital decay that you would experience on Earth when you're not in orbit. If you're traveling somewhere else, then you do have to manage the fuel usage with not only with your straight trajectory, but when you encounter whatever the target is you're going to, you would need some fuel to slow down and enter the orbit correctly. At Christo CS asks, do spacesuits fit well? Are they even remotely comfortable? As best as you can get them. You're not going to a tailor, but they do their job. I think they're adequate. Are they even remotely comfortable? Yeah, they're all right. You know, you wouldn't want to wear one around town necessarily, but for what their function is and what they need to do to protect you, yeah, I would say they are comfortable. At Kayo Pajinkuk, hashtag Ask NASA. As an astronaut, how many languages do you have to learn to be able to communicate with the crews from other countries? It's not just English, right? That's true. It's not just English anymore. For going to the International Space Station, if you're going to operate and work there as a NASA astronaut or as an astronaut from the European Space Agency or Canada or Japanese Space Agency or the Russian Space Agency, you need to be able to speak two languages. Because it's Russian, the Russian segment, the US segment. On the US segment, we speak English as the primary language. On the Russian segment, it's Russian. On the US side, you needed to be able to get along pretty well in Russian, and the same for the Russians in English. So, yes, 2 languages required on the space station. At Christine12272 asks, my wife just turned to me and asked, baby, do you think space smells? I have no idea how to answer this question. So if you're inside the cabin, you're in a pressurized environment, and space will smell like things smell here on Earth. If you're smelling food or each other, use your imagination, it'll smell the same. The question might be more of what does space smell like? This requires a longer answer, but we're not doing a longer answer. We're gonna do a short answer. It has I gotta go with the long answer. When I was a new astronaut, Sergei Krikalev, a Russian cosmonaut, he had been on Mir a few times on Space Station Mir. He'd just come back from a shuttle flight, and he said there was a very distinct odor. You come inside the airlock, you close the door to space, and you open the door to the spacecraft inside. When you enter that airlock is what Sergei told me. It was the same smell on Mir as it was on the space shuttle. It doesn't last for long because that air starts to mix with the air in the cabin and the smell goes away. But on my first mission, I wanted to check this out. So sure enough, after the first spacewalk, I was not outside. I was inside for the first spacewalk, helping the guys outside. As soon as the spacewalk was over, I opened up the hatch. I went in there, started smelling. I've got a good nose for smelling. And it was this very metallic smell, almost like a burnt metal smell. It's very distinct, and I like to think that's what space smells like. At Almira AMRCL asks, Mike Massimino is in Big Bang Theory. Yes, I was on the Big Bang Theory.
Hey, Fruit Loops, want to hit your fan switch?
That was a very cool experience. I got a chance to be on the show. The way that happened was NASA called me up and said, hey, Mike, do you know about the Big Bang Theory? And I said, yeah, it's this big explosion and the universe is expanding. He goes, no, the show. And I was like, yeah, I think at that time I wasn't that familiar with the show. I'd kind of heard of it, but he said they wanted to speak to an astronaut about sending a person to space. And I happened to be in Los Angeles maybe a couple weeks later. And I went by the Warner Brothers studio to the writer's room, which was extraordinary. Bill Prady and Chuck Lorre, the creators of the show, and their writing team was there. And I told them stories, kind of like I'm telling you now. And they wanted to work some of these ideas into their scripts. So I helped them a little bit with that. I went to see a taping. And about 6 months after all this, I got a note from Bill Prady, one of the creators, and he said, hey, Mike, we'd like you to do a cameo. What do you think? And I was like, okay. So I went in and I did a cameo, and that led to 6 more. And a lot of good friendships out of that with the cast and the crew, and it was a great experience. The point of all that is, sometimes you just need to say yes. Thanks for all your questions. This has been Space Support.